Hello, everyone, and welcome to our latest Code Presents webinar, the age of AI, GPT, Azure OpenAI, and Copilot. We're excited to have our fearless leader, company founder, and AI expert, Markus Egger, presenting for us today, and we've got a really good one lined up for you today. AI is all the rage these days, and you can't flip to a news or financial news channel, read a magazine article, a blog post, or a social media post without coming across something related to AI. Fortunately, we're not talking about the scary Skynet, Terminator, Sarah Connor kind of AI here. We're talking about the AI that's available today to help you and your organization be more productive, better serve your customers, and ultimately thrive. Today, Markus is going to talk about the state of AI and that drastic change it's going to have on the software industry, and business in general for that matter. We're at a pivotal point in software development. Code written before AI, code written after AI. I know I'm getting ahead of things here, so I'll keep moving. My name is Jim Duffy, and I'm responsible for the marketing and sales efforts for all of the Code Group services, including Code Magazine, of course, but the Code Group is so much more than just a magazine. The Code Group's continuing mission is to help people build better software. For nearly 3 decades, we have provided a number of services, including building custom software solutions on-prem and in the cloud, modernizing legacy applications like VB6, Access, and FoxPro, educating developers with webinars and training courses, providing strategic developer resources to augment your development team, supporting and maintaining existing applications, and now you can look to us for AI consulting services as well. Our team of expert developers and consultants are ready to help you with your project. When you join our code staffing organization, you become part of a company that values you as an individual, not just an employee. A place where you're not just a number, but a crucial member of the team. A place where you're appreciated, celebrated, and invested in. That's the kind of workplace that Code Staffing strives to create, and our employees are at the heart of it all. From our industry-leading benefits, to our regular trainings, to our twice-a-year get-togethers, you can be part of a team that loves working and growing together. In short, at Code Staffing, we don't just hire employees, we invest in them. We believe that our employees are going to be the key to our success, and we're committed to doing everything we can to support them. So, if you're looking for a company that values you, that invests in you, and that truly cares about your well-being, then look no further than Code Staffing. Join us and become part of the team that's changing the game in the staffing industry. Check us out. We are different. We're better. We are hiring across the entire Code Group, and we need you. Check out our current openings at codestaffing.com/careers. As I mentioned, we're now helping companies leverage the power of AI to help them succeed in today's competitive marketplace. You may not think you need to use AI in your business or add AI capabilities to your software applications, but odds are very good your competitors think they need to and/or are planning to do so very soon. Ignoring AI puts your organization at risk for being leapfrogged and left behind, playing catch-up with your competitors. Contact us for more information to schedule a free demo and/or a free brainstorming session. If you like what you see today or have seen in our prior webinars, please subscribe to our YouTube channel, follow us on Twitter, like us on Facebook, and follow us on LinkedIn. Code Magazine is the leading software development magazine written by expert developers for developers. All registered attendees who don't already subscribe will automatically receive a free digital Code Magazine subscription. I've also included a free subscription link here for you to freely share with others who couldn't make it to the webinar. The Code mobile app is available for both iOS and Android. It's the ideal way to read Code Magazine on the go. We have a number of events coming up, including our State of .NET Microsoft Build Recap webinar on May 31st, our Secure Coding for C# developers courses in June and September, and our new full-day Introduction to Development with OpenAI, ChatGPT, Azure OpenAI, and more on June 21st. Pick up from where today's short webinar ends and join Markus Egger for an entire day as he digs deeper into AI concepts, tools, and coding examples. For more information and to register, head over to codemag.com/training today. We would like your feedback about this webinar in the form of a very quick survey. The survey will be available once the webinar has been underway a bit. We want your feedback, and we're willing to pay $100 in the form of an Amazon e-card to one lucky attendee. A name will be drawn from the list of the completed surveys. The survey link is on this slide, and we'll post the survey link in the chat window as well. The slides and recording of today's webinar, and all of our webinars, will be available on the Code Presents page on the Code website. All registered attendees will receive an email after the event directing you to the slides and the webinar recording as well. Our presenter today is Markus Egger. Markus is the big shot around here. He's Code President and Chief Software Architect, publisher of Code Magazine, international author and speaker, Microsoft Regional Director, a very knowledgeable and talented developer, and our resident expert in all things AI related. If this is your first time attending one of our webinars, welcome. Thank you so much for joining us. If you've attended one of our webinars in the past, welcome back. Okay, you've heard enough from me. Thanks for listening. Take it away, Markus.
Well, thank you very much, Jim. Good morning, good evening, good afternoon, wherever you might be in the world. Excited to see a full room online in the live version of this. I know it's pretty early where I'm at, so if I'm a little tired, I think that's part of the reason, probably why that is. Part of it is I'm super excited about the topic that we have at hand here today, probably more so than I have been in the last 30 years. I'm up late at night, and that was true yesterday, just working on this stuff, playing with this stuff. It is very, very exciting times indeed. So welcome everyone in the presentation. Let's take a look at what we're here to talk about today. This is an interesting kind of talk. We're in a Code Presents event. Normally when you see me online, I do Stata.net webinars. Stata.net are more skin deep and broad in the topics that we have. This is more focusing on a single topic and drilling in more deeply. So obviously we're here to talk about AI and AI capabilities, in particular around the OpenAI offerings, and especially the conversational part of the OpenAI stuff, which is just all the rage lately. The last 4 to 6 weeks have probably been among the craziest in my professional life, and I mean that in a very, very good way. I really can't remember when I've been as excited about technology the last time. So that's what we want to talk about today, but we got to start with the fundamentals. We got to start talking about what are these things, what are the implications. There's a lot of uncertainty around a lot of the things that are now happening. It seems like magic to a lot of people, but it really isn't. So we have to talk about some of the fundamentals, the big picture, the capabilities, what to expect. I know that we have a lot of people in the webinar today that aren't necessarily developers, and I think you'll also get a lot of value out of this. But then, of course, we do have a lot of developers. And as we get into the second part of this presentation, we'll talk a lot about the under the hood stuff, how to do this. But it's a different developer world. And again, I think even some of the non-developers that I know are watching this today are going to get some pretty good information out of that. We are fundamentally talking about AI, OpenAI, but what that also means is we're talking about copilots. Copilots are a new paradigm of software development. It's a huge shift in industry. It's probably bigger than you think it is, even if you've already looked into it quite a bit. It's a shift in how we do things, just like we had a shift from DOS to Windows, from Windows to web, from web to mobile. There's various big shifts I've seen in the industry throughout my career, but this is as big as any of them, and it's coming much faster than any of those other shifts that we've seen in the past. So that's the overall idea, and I hope by the time you see the end of this presentation here, you come away having a decent understanding of what we're trying to do, where this is all going, what is and isn't outdated at this point, and you'll discover, as we have, that what we did even earlier this year is now pretty outdated, and it's moving extremely fast. So we'll go through a lot of the slides here in the beginning to go through some basics, and then as the presentation moves on, we'll talk more and more about code stuff. So if you feel it's too many slides at first, hang in there. We're going to get to the other stuff as well. And by the way, this is a live presentation. Feel free to ask questions in the chat. I will look over here on occasion. I have my minions watching the feed that will answer some questions directly, and they will also pass questions on to me here, and I'll get to it either in the middle of the presentation if it fits well, or towards the end of it, and I won't leave until we have all our questions answered. So That's it. Let's dive right in and let's talk about AI in general. I'm going to try to go through this relatively quickly. I did a Stata.net presentation on that, both online as well as at a few live events we've been doing again. Yes, we've been doing live Stata.net events again, so it's good to see some of you in person. And I did a longer version of that there, and that is still available as a recording. So feel free to watch that, but we're going to go through this relatively quickly here to make sure we're all on the same page. So what is artificial intelligence? And I say, what is artificial intelligence and machine learning? Because they're really the same thing as far as we're concerned in this presentation here today. In a way, artificial intelligence is a marketing term, like I always like to say. Is the machine truly intelligent? I think that's debatable, but I would say the answer at this point is, from my point of view, clearly still a no. We're working towards that. I think it's also an academic exercise. But whether it's truly intelligent or not, I think is a secondary question. What's important is we have the ability now for a machine to perform tasks in a way that appear to be intelligent, right? And we can debate what intelligence is in this sense, in the machine sense. We can also talk about intelligence the way it is in any sense. What does it mean that humans are intelligent? What does it mean that certain animals have a certain degree of intelligence? All of that, I think, is highly debatable. It is a discussion that for the majority of the human existence was a very intellectual, philosophical type of discussion, which in the last few weeks and months has turned very, very rapidly into a very concrete debate that's of very high significance. For our purpose here, intelligence is basically, for the most part of computer science, it's been basically what's just beyond of our capability to do. You know, tomorrow we'll be able to do X and that will be intelligent machines. And in some way, that's still the case. It's always that little magical next step. But in a lot of ways, we've just taken that step. So some of the things we're now doing, some of the things that I'm going to show you here in this presentation today, even 3 months ago, 4 months ago, would have seemed almost impossible and like science fiction. So it does feel today, when we play with some of that technology, it doesn't become mundane anymore. It doesn't become, oh yeah, that's how it does that. But while you're working with this, it does seem pretty amazing. But it clearly isn't true intelligence. It's a machine performing statistical math. It's, especially for the stuff we're going to talk about today, it's a calculator of words. It's a very advanced calculator, but it's statistical tricks. It's not something that has its own will, its own desires, or anything like that. It's really just pieces of code that run as we spin it up. And that's all we're talking about. It's pattern matching, it's mathematical tricks, statistical math. It's performing tricks, but it's performing those tricks extremely well, as you'll see. So that's the big news, really, is the kinds of things it can do. Here are a few examples of what it means when a computer is intelligent. And some of those you'll say, well, those are mundane, they're not true intelligence, like searching for data, finding data in a SQL database. Well, that's not what we would consider intelligence today, but it is interesting that when you think about it, it really is, and it's intelligence at a level that humans can't do. The task of searching data in the way a SQL query statement does is really superhuman in its intelligence and in its ability to do that. But of course, we think of this as a mundane task. It's just brute force, basically. But that would be an early example. More like real intelligence would be something like playing chess or Go, which was for a long time something that we considered is beyond of what computers will ever be able to do. We thought computers would have to be cunning, they would have to be deceptive, they'd have to be wise, they'd have to judge the opponent to outperform a human player in chess, and especially Go, which is more sophisticated in that sense than chess is. But as it turned out, it didn't take any of those things. Computers are now better at playing chess than humans are. Computers are better at playing Go than humans are. They have beaten humans years ago. Occasionally you hear about a human beating the best AI Go player, for instance. But that's big news then if that happens once in a while. Computers in general are just better at this. And of course, we humans still enjoy playing chess or Go. We enjoy watching other people do it. we don't enjoy watching computers play each other, right? It hasn't really diminished the game of chess or Go, and in fact, it probably has more people playing that today than ever in history. So interesting characteristics to ponder there. What else do we have? We have things like making interesting predictions, user input, predicting the stock market. Those types of things are typical AI tasks. And they require models be trained in a neural net type of sense. We call that deep learning, where we build up these models. We try to replicate what humans do in their brain and the neocortex. It's a very, very rough estimation of what we do in there, and we're not even really sure how the neocortex works, of course. But we're trying to approximate what we know with these neural nets, and it's working out very, very well. So making prediction like, what's the most likely thing you want to watch on Netflix has improved dramatically because of neural nets. And those have been around for a while and are examples of intelligence beyond of what we had just very recently even. A completely other area is visual and audio recognition, analyzing what's in an image, facial detection. I have a friend who's in the business of detecting whether people smuggle arms into large sporting events and that sort of stuff. And that is largely a solved problem. We're doing very, very well with that. Audio recognition is getting very, very good. Humans are getting better at transcribing human speech than humans are at listening to other people talking. So a lot of stuff there is working really, really well and has come a very long way. And also machine translations have become really good. And we don't do that by making rules and say, if the English sentence includes this, then the Spanish sentence needs to be like that. Instead, we're training up models on oodles of data, and we create these neural net models. They're not like algorithms that go through something step by step, but they're trained mathematical models that approximate and describe things that happen, in this case, text, and then what the outcome should be. So interesting how that works. And then we could get into a multitude of individual examples, like creating a legal contract. My better half is an attorney, and attorneys for the longest time used to think they're irreplaceable, and how could a human ever understand what we need to do? Well, the reality is, no, they're not going to be replaced, but the humans do now do a big part of the job that attorneys do very, very well, and assist the human attorney in that task. And I think that's where we are at. It's mostly not humans computers taking over, but it's mostly about computers assisting the humans. That's where we are. So there's different waves of artificial intelligence we can talk about. This is one way of splitting this whole thing. There's the internet AI wave, which is things like Amazon and similar sites predicting what you would like to buy and predicting prices and so on. So when you ride in an Uber car, they do a good job at predicting what the price level should be at any point in time. Or when you go on Netflix, it tells you you might want to watch this other movie based on your general likes. And that was kind of the first wave of true AI, as we have recently understood it. Now, there were waves before that. AI has been around for a long time, and we've gotten our hopes up, and then we discovered we're reaching the limits with things like expert systems. And then we had what we call an AI winter, where the excitement about AI dipped down again. And then we had another resurgence and another winter. And this has been going on for decades now. This is not that new. But what has happened very recently is two things. First of all, we have enormous amounts of data at our disposal, and we have enormous amount of processing power at our disposal through the cloud. So since we now have both of these key components that weren't there before, the training of things like neural nets, the deep learning algorithms, have become much, much more efficient. And that's what made this wave possible. Now we're going to hit the ceiling with this wave, and we discover, oh, this is not how we can make machines truly intelligent. Yes, I think I would not at all be surprised if we hit that ceiling again, and there's more research and we need a multitude of breakthroughs to get to real intelligence. But that's not the point. The point is that what we are now looking at with some of the things I'm going to show you today is so tremendously useful that we'll be sticking with that. Just like prior waves, we have all that functionality available to us, and we'll continue going forward with what we have now, regardless of whether we call it truly intelligent or whether AI is just a marketing term. So, the first wave of the internet that truly used that modern AI was the internet AI, I should say. We then had business AI, where some of those things were applied to businesses like insurance companies being able to make more sense of data and providing more appropriate or inappropriate at times versions of insurance, or oil and gas exploration companies using some of this data to do a better job at where to explore for oil and gas. So that's interesting, another next wave. And then the next step was perception AI, better audio and visual AI. So that was in the last few years is when that really happened. And then finally, the next step is autonomous AI, which is AI that truly does things on its own, like self-driving cars or virtual insurance agents that'll take over what the human does. We're not there yet, and that might still be a ways in the future. Some of this will require several generational breakthroughs, so that's not truly around the corner. So we're somewhere between the perception AI and the autonomous AI stage, I would say. So there's a question online. So with these neural nets, do we actually know what these neural nets do? And that's a very interesting point. It's often very difficult to understand how a neural net makes its decision. There's a lot of research going on around that, and making that more and more explainable is something that we certainly are working on. But Eric, who's asking that question online, is certainly correct in that that's a key area of improvement where we want to get better, because as these models get larger and larger, it becomes more and more difficult to predict why that happens. And in some of my other presentations, I do some interesting things. For instance, I have a visual recognition example that takes retina images of the human eye, which is something eye doctors use, and where eye doctors were always of the opinion that there's no difference between male and female retina images, yet you can train an AI that finds mathematical differences and can actually predict that very well. But it's very difficult to say, why does it know what the difference is? It's just such mathematical nuances that humans can't comprehend it, basically. And then saying why it found that is a problem. And then we have a problem in things like self-driving cars, because, hey, why did this car make this decision and got into an accident? So those is certainly difficult problems to solve. And they're the same with humans. Why did my human driver make a certain decision? It's often very, very difficult to say. And this generation of software we're now looking at has that characteristic, and we're trying to make that better. So another question there is, so if AI is a pattern recognition process, and we train that AI, that neural net, on existing patterns, can it then actually extrapolate to other patterns? And the answer is yes, because it performs approximation. So the characteristic of it is that it can extrapolate into things that it hasn't seen before. So for instance, when we predict the price we predict isn't necessarily a price we've ever seen before, because we are applying math and it can fill in the gaps. However, with some of the stuff that we're going to specifically talk about here later today, it isn't that it can intelligently reason beyond certain things that it learned in its pattern. So when we talk about speech, for instance, we'll talk about those details, but it's not going to be able to just make up things that humanity has never been able to, because it reasons better than humans. But it can certainly fill in the gaps in terms of speech and say, if we wanted to make up a story, and it has learned about stories that involve dwarfs and princesses, and it's also learned about stories that involve people that live on foreign planets or in outer space and fly with spaceships, then it could probably make up a story about people in submarines, even if it has never heard such a story. But it's not going to be able to then become super intelligent and learn how to exist on its own and produce submarines. That's a different story. So it's not intelligence in that sense, but it can fill in the gaps. Okay, moving along here in our discussion. Another way of learning or differentiating AIs is this categorization. There's what I would call a dumb AI, like the searching for data in a SQL database. Fine, we'll ignore that for now. Then there's shallow learning, relatively simple model training that we can all perform on our own. And I've shown some examples in Stata.NET events and others where we use machine learning to do things like spam recognition, and we train our own models for that. And it's reinforcement learning, but it's relatively shallow learning. Then there's what I would call deep learning, and that's what today's session is mostly about. And deep learning is something that truly takes a massive amount of data and gets trained with a massive amount of computing power to perform pretty amazing tasks. And so, for instance, when we talk about advanced chatbots, as we'll talk about today, that is a deep learning model. In fact, it is numerous deep learning models combined. And it is trained on vast amount of data. In the case of ChatGPT, it's basically trained on all the publicly available written knowledge that's on the internet. And it takes months to train these models and massive amounts of processing power. I mean, we are talking data centers that are a mile long and a half a mile wide, full of machines used to train these models. And that's what we call deep learning. It's to some extent something we can do on our own for the simpler deep learning models. We can run that on our machines or a handful of servers maybe. And then on the big end, the most exciting stuff that we can see today is just things that literally take months and months to train. We differentiate between narrow AI and general AI, general artificial intelligence. Narrow AI is where I think a lot of it is at. It's where AIs are trained to perform specific tasks, such as create spam filters, such as predict what movie you want to watch in the future. Those AIs have a specific task, and they are essentially trapped within that. The AI that filters spam is a simple mathematical algorithm that runs on some server somewhere, like any other program. It could be a C# program or something like that does it. And I can call it and it gives me an answer back. And I can run one instance of it. I can run a million instances of it. I can start it up and shut it down. And it's just a piece of code that runs. And it does sometimes amazing tasks, as we see with the OpenAI stuff, but it's narrow AI in that it performs one task and it will never learn more. The spam filtering AI does not get bored and learn how to play chess. It just can't. It's really a fancier version of a calculator that says calculate two numbers and return it. It's made for what it does, and it will never be beyond that. General artificial intelligence is something that approaches more the human type of intelligence, where we can do things like look at an email and say this is spam, but then we get bored and we learn how to hang glide, and we learn how to play chess, and we learn all kinds of other things, and we learn how to be a woodworker, and we make things and so on, and we break out and we reason and we learn new stuff from other people. And that's general AI. And there's a lot of concern around general AI. When that becomes very large and more smarter than us, the reasoning goes, it could become very dangerous potentially, even though it also has a lot of really beneficial attributes. Now, it's important to understand that we are nowhere near general AI. Companies like OpenAI have the goal to ultimately create general AI, but we are a number of generations away from that. Like I said before, what we are trying to do right now is we're trying to approximate what the neocortex does. That's the modern part of the human brain. 70%, I think, of the human brain is neocortex, and it's what we use to reason, and why I can sit down and write a slide deck and tell you about all these programming topics today, and a fish cannot, for instance. That's the neocortex does that for us, and especially the human neocortex. But then we also have these old parts of the brain that make us do all kinds of stuff. Like I don't need the neocortex for my body to know to breathe, for instance. Even though I'm now focused on giving this presentation, I keep breathing and I don't have to think about this. Well, there's parts of my brain that make that happen. And there are also the parts of the brain that make me do stupid things, that make me go to the fridge and eat another piece of cake, even though I know logically through my neocortex that I shouldn't do that. But that part of my brain overpowers me ever so often, and I go and I do something that I shouldn't. And in terms of computer AI, we haven't even thought about reproducing that. And frankly, I wonder why we would. Like, it's nice to have things that happen in an automated way subconsciously, but we do that in computers in other ways. And I think, academia is going to have an interest in replicating that. But I think we're going to have parts of the human brain that in an economic sense, in a true production sense, make very, very little sense to put in an AI. At least that's my take on it. Interesting differentiations there. Now, one of the things I want to point out is people now start talking about generally useful AIs. AIs that are trained narrowly, like on the topic of speech, for instance. They talk a good talk, but they can't do anything else. Yet they become so generally useful that we start using the term general useful AI, basically, or slightly different versions. And I think people are going to start confusing GAI, true general intelligence, with generally useful AI. So we're going to hear a lot about things like ChatGPT and OpenAI being generally useful, but they're not GAI. And there's actually some very interesting talks. Like, for instance, I was just listening to a Lex Friedman podcast that he did with the CEO of OpenAI, and they talk about that. And OpenAI does not consider ChatGPT to be GAI, even though it's generally useful. So that's an interesting distinction. Now, there's a question online from my friend Mauro and former colleague, regional director. And he says AI can behave in homophobic fashions and other undesirable things. And that is true. So you have things like chatbots that are trained on all this data. And unfortunately, humans put out a lot of racist and homophobic and other undesirable content. And that also flows into training. And then we're trying to make these AIs understand. So for instance, there was a very well publicized case where an older AI that Microsoft did a few years back, a chatbot, became homophobic and racist, and they shut it down. The more modern AIs don't seem to do that as much. And the good news is you can teach these AIs that certain things are not okay and are offensive to certain people, and then they can correct themselves and not do it anymore. So we're getting better at that, but I think it's a reflection on the darker sides of humanity that AI also learns those things, and we should put rules on top of that. And by the way, a lot of people say, oh, well, a lot of this AI stuff is very dangerous. And the answer is yes, it is. It's an enormously powerful set of tools with enormous beneficial upsides. But like anything powerful, it can also be used for ill intent. Now, the good news is it's a little bit intelligent, even though it's not truly intelligent yet, is we can still teach it things. So while if I have a hammer and people use hammers to whack other people in the head, I cannot teach a hammer to not function as a hammer when a bad scenario happens and a criminal is using a hammer and is about to swing it at another human being. But with AI, I have at least some ability to put rules in place and say, oh, no, that's not allowed. And then the AI doesn't do it. So yeah, it's a concern. And a lot of people worry about that. But I think it's a concern that is starting to be under control, or at least we're trying to, and it's better than with many other tools. But it's a valid concern, and I'm glad a lot of people are focusing on that. And I think we have enough people focusing on that. That's an important point. I think it's not a problem that goes overlooked. And a lot of people are worried about it that are just exposed to AI for the first time. But I don't think we need this huge awareness campaign of the bad sides of AI. I think people are well aware of those types of situations. So on the topic of the superhuman intelligence is, what does it even mean to be superhumanly intelligent? And that's actually, again, a philosophical question that just became very pressing and concrete and is taken out of the philosophical realm. Like, what does that mean, superhumanly intelligent? Does it mean the computer is faster? It can reason faster? Well, it already does that. Does it mean it can memorize a lot more and not forget? Well, it already does that. Can it consider many more factors that go into something? It already does that. All these things have been done for a long time. Can be more complex. It's more accurate. Pattern matching, humans are probably still better. But let's say the computer does get better in general at pattern matching. There's many areas where computers are already better at pattern matching than humans. You know, do they make fewer errors and so on? And so we can go through a lot of the long list there, and we discover we don't actually know what superhuman intelligence means. We're totally lacking the vocabulary to even talk about that. So that's very interesting to ponder. And the fact that the computer is already better in many of these scenarios than we are hasn't led to the computers taking over the world at this point. But it's theoretically possible that they would at some point. But my point is, it hasn't happened yet, and it won't happen with the current generation of AI. Maybe 3-4 generational breakthroughs down the road, yes, that may be an issue. We will probably get there at some point. And when does it matter? There's this concept of the singularity. The singularity is this one point in time where computers get better and smarter than people, and then the theory is that some people have, it's then going to happen so fast that this thing reinforces itself and learns about other things that we as humans just don't stand a chance. And I'm not a big believer in that because, first of all, I don't know what the singularity really means. Like, does it mean the computer is smarter than me? Does it mean the computer is smarter than Einstein? Does it mean the computer is smarter than the collective intelligence of humanity? And you know, depending on how you define that, I mean, okay, so there's probably a lot of people that are smarter than me. They don't necessarily take over the world and leave the rest of us behind. So it takes more than just a little bit smarter. And I think, you know, we're a long way from that. And again, I think it takes things like the other parts of the brain to really make that happen and do it in a malicious way. But then there also is things like the alignment problem. Alignment problem basically means our computers aligned with our desires. And that's an interesting question. And again, a lot of people are worried about that. I think humanity in general does not need to be more worried about it than we already are. It's well worried about, let's put it like that. And people think about things like, well, what if we tell this super intelligent machine to just make paper clips? And it just runs away making paper clips, and it becomes so smart that it turns the whole world into paper clips. And then, you know, flies into space and does the same thing with the entire galaxy. And I'm just sitting there thinking, well, you know, if we make AI that's so intelligent that it could do all that, is it then really in line with it not understanding that the task is silly and it should really change course? Just doesn't seem to line up very well with me. But it's a valid concern and people are worried about that. But again, this is not what we are talking about today. What we are talking about today is much more simple statistical math, even though the results are plain amazing. So today's AI is not generally intelligent. It's not conscious or self-aware, even though there's a big debate around what that means. Is ChatGPT conscious? Well, it's often when you work with it a lot, it sure seems like it. And there's articles that one called Glimpses of Consciousness in ChatGPT, for instance. But it's not conscious in the sense that you and I would understand the term. Again, the term is very ill-defined, and it becomes important now all of a sudden to define that better. And perhaps one of the things we'll discover is that human consciousness is not this magical attribute. Maybe it's just emergent behavior of a slightly more intelligent thing than we are able to build in the computer currently. And I think that's very likely. I think, you know, there's few things in nature that we discovered that the cause is magical. It's usually very small, trivial building blocks adding up to something enormously large and then having emergent behavior or emergent features. So we'll see where that leads us. But currently, these systems are not conscious or self-aware. They're not cunning. They may pretend they appreciate humor, but it's really just statistical math telling it that it should respond by laughing. It's not actually understanding humor. It doesn't have its own goals. It doesn't sit there when we're not using it, and it doesn't say, oh, I'm bored, I should now think about how to take over the world. It just doesn't have these goals. It's a calculator at the end of the day. So lots and lots of things that it isn't. It's also not a person. Us humans, we like to put these attributes on things as if they were people. And for AI, that is particularly likely and dangerous. So ChatGPT, we often talk about it as if it was a he or a she. It is not. It's a machine. It's an algorithm. It's a piece of code that runs. It's also not one piece of code that runs. It's not this one thing that sits there and it may break out one of these days. It's pieces of code that we fire up when we need them. We shut them back down. We're not killing it. It's just code that runs or doesn't run. And we start up millions of instances of it. It's many, it's like microservices, right? It's many small programs running, get started, get stopped. It's not a person, even though we like to think of it like that. It's just code running, and humans just think about it wrong, because that's what humans are. We see agency everywhere. We see, there's people that see faces on things other than heads, and they think that's because we are pre-trained. Our brain is pre-trained to see people and animals and things with agency everywhere. But this is not it. It's a program. It's not a he or she. It's an it. It's just a thing that runs. And that's what we're talking about there. Quick side note here. When we talk about AI, we talk about software. We're not talking about robots running around doing things. Robotics is way behind AI. And AI can be rolled out very, very quickly. When I make an AI that can do something, like say, design the interior of a home, I deploy it, and tomorrow it's available to the world, and it can be available very, very cheaply. The same is not true for robots. First of all, we are not even close to being as good in robotics as we are in AI software. But secondly, even if we were, robots would be expensive. They take a long time to build. And, if we had the best robot in the world, it would take a long, long time to roll that out to humanity at large and have 1 billion of those guys, right? So different thing there. So there's no real need to be scared of AI in the sense it will take over in the world, but it will have a massive impact on the economy. There's no question. I believe we are becoming witnesses to one of the biggest shifts in human history, and I think this is happening very, very quickly. I think this is on the scale of the Industrial Revolution. I think it's actually beyond the scale of the Industrial Revolution. And the Industrial Revolution took a long time. It took a long time to build all these factories, and people changed from being farmers to moving to cities and living a better life and all that. AI is coming much faster. ChatGPT was rolled out last November, December, and now in no talk I ever do have I had a person that has never heard of it and hasn't used it. Everybody pretty much has tried that. And it's just available. It's only been a few months or weeks, really. So this wave is coming extremely fast. It will change a lot of things, and it has a huge impact on the economy. We are estimating that by 2040, 2050, more than half of all the jobs could theoretically be replaced by AI. Now, whether we do that or not, and in what parts of the world we do that, different question. But, that is a possibility, and that will have an impact on society and the economy that we will have to be very, very careful managing. I've been very outspoken that I think some of the things we are now doing with AI leads to AI apartheid, where we are not spreading that love equally. And even a company like Microsoft that is super serious about ethical AI and has been voted the most ethical company for several years in a row now, I believe. But even Microsoft, I think, struggles in how to roll out these things and make them available to everywhere, because we do have limited availability. So who gets it? Is it just a strategically important partner? Is it the universities? Is it the young up and coming company done by two women in their garage, and they're trying to build this AI company, but they're just not important enough to get access to some of these features? So that's where I've used the term AI apartheid, and I think we have to be very careful to not create that. And I think we need something like AI neutrality, kind of like we need net neutrality on the internet. We need AI neutrality, and hopefully this time not mess it up like we did it with the internet, because AI is going to produce winners. And I think in the long term, everybody is going to win through AI, but in the shorter term, there'll be a lot more losers than winners. And, we'll all be struggling, falling on the right side of that divide, but we also need to make sure that we make that divide go away as much as we can, and that's not just going to happen by purely capitalistic means or similar things. So winning the AI game takes a few important factors. Here are the 4 or 5 most important ones. Number one, data, and data. Data is the number one thing that made this new wave of AI possible. We need vast amount of data that are freely available. And if we limit that, the AI in that area that this becomes limited is not going to succeed. And this area may be a certain industry, or this area may be more likely a geographic region. I think there's going to be some parts of the world that are going to make that very freely available, and other parts of the world, like I'm originally from Europe, I'm very concerned, even though I understand the data privacy that Europe wants to put in place, but at the same time, is it worth becoming the next generation third world region that falls way behind economically everybody else, just because you don't make data available? Second pillar is the availability of compute power. We now have that with the cloud. We have supercomputers available to all of us, basically. And again, that made it possible to process those amounts of data and enabled these large neural nets to be trained. So we have those things available pretty much everywhere we want them to. Then we need things like funding and a culture of entrepreneurship and high-risk investments into a lot of these new endeavors. We need well-trained AI scientists, so there's the university ecosystem, the learning ecosystem in general. And we need political support in an environment that allows for it. We have already seen examples of people that don't allow for it, or countries like Italy trying to ban ChatGPT. Okay, so if you don't have that political will, AI is not going to happen. And some people might say, well, that's great. But when you then consider how fast the rest of the world will progress, and overall, even with all the hardships we'll have, overall lead into a world where so much more is going to be available to everyone at a much lower entry barrier, it's clear that those that don't play well in these scenarios will fall behind very, very rapidly. And so you can now think of the environment you are in, whether it's a country or an industry, and make up your mind as to how well your area is going to fare in all this. Because there's a question online and says, if AI learns from existing knowledge, will AI reach a point where it cannot learn anymore without creating its own knowledge? It's an interesting question. I think we are far from that point. And even from the current knowledge, we draw and we train these models in more and more complex and layered ways. So for instance, when I just talk about speech, I can learn relatively simple patterns, and then I can move on and add more layers of more and more complex patterns that do better in predicting the speech. And I think there's going to be a long way ahead of us mathematically of coming up with more and more ways of training it better. But yeah, theoretically, we'll eventually get to that. And then we'll experience another ceiling that we hit, and where these just statistical math type of AIs will not be able to become better and just reason on their own. And again, we're not generally intelligent yet, so as far as the machine goes. Now, here are a few things that I recommend to you, a few books that I enjoyed reading. AI Superpowers is a very interesting read. It's a factual read, but it almost reads like a novel in some ways. So I definitely recommend that. It's now a few years old, but it's still very, very applicable with what's going on and who is well situated in taking advantage of these AI waves. And by the way, spoiler, it's going to be China and it's going to be the US that are currently by far in the best position. Another book is Superintelligence. That's more about what happens when this thing becomes more intelligent than us. It's a very interesting read. If you're interested in any of this, you should read it. It's a much harder read than the other book. And at times it's truly out there. And I think it's way ahead of what we need to worry about today. But nevertheless, it's interesting for those that are into this sort of stuff. Another book that I really like is AI 2041. This is a book that's half novel, half science. So it has 10 different chapters, 10 different short science fiction stories about AI. And then each chapter, about half of it is then devoted to the factual part and explaining how those things can be built in software and are likely going to be built in software. So an entertaining read. It's a novel style read, but then it's also technical and factual and highly recommended. And then finally, 1,000 Brains is a very interesting book. It's by Jeff Hawkins, who's also the founder of Palm. So for those of you who still remember the Palm mobile devices, this is the guy that started that. But at heart, he's really a neuroscientist. and returned to that field and is doing a lot of research on how the brain works. And this book is an explanation of what we know about it so far. So it's neuroscience, but readable for the everyday person. It's a very readable book and very interesting. And I definitely recommend you take a look at that. So moving along here, let's talk about AI in practice today. So what are our capabilities today in concrete terms? We have narrow learning, so within a specific field, like driving a car, like classifying spam, like translating speech, and so on. And we have that on a deep and a shallow level. And the deep level is becoming more and more interesting, where we have these truly large and amazing models that are done for us. Usually we don't train those ourselves. They're just too large. We just use the ones that are there. Although some deep learning in specialized cases, as I've shown in some other presentations, we can do ourselves as well. But it's not at the level that we are talking about for OpenAI today. We have no real general artificial intelligence. We only have generally useful artificial intelligence, which is a big difference, although in a great tradition of computer science, we create these competing and confusing terms. Nevertheless, even though it's not generally useful, the results that we achieve today are just mind-boggling, right? So what we do is we take these AI services, we build them into our apps and systems. We usually develop against pre-trained models, although we also supplement with training our own AIs. And in the pre-trained scenarios, there's a number of players that become active in this. There's Amazon, there's the Googles of the world, the Metas, and so on. But today we're focusing on Azure, and Microsoft is very, very well positioned to be the leader in this area, especially in the Western world. So Azure Cognitive Services include things like speech services, language services, various computer vision and decision services. And those are things, if you're interested in those, watch my State of .NET presentation on the state of AI. We talk more about that there. What we are really interested in today is what's called the Azure OpenAI service. So what is OpenAI? Okay, OpenAI is a company that's incorporated in the San Francisco area, started in 2015, was started by, I think, a dozen people, one of whom was Elon Musk, by the way, but he was just one of the many players. He likes to make it sound like he started it. He did not. He became involved in it, then exited because he didn't see the benefit in how this could ever make money, which makes you kind of scratch your head looking back on that now. So there's, a dozen other people that started this, most of which are still involved in it. Microsoft is involved in it. They made over time about an $11 billion investment, as far as we know, with $1 billion earlier and $10 billion relatively recently, with which they control 49% of what's called the OpenAI Limited Partnership. That's a for-profit version of OpenAI, but originally it incorporated as a non-profit called OpenAI Incorporated, that's still controlling part of it and is still there in the background. And OpenAI is not open source as such, even though they open source some of their stuff, but it's certainly much, much more open than many of the other players we see. If this OpenAI wave would have come from Google, I predict we wouldn't have seen nearly as much openness. And we know, in fact, because Google does things like Bard, which is competing technology to GPT, and we know it's less open. But it's not truly open source, and they have open sourced some of their models, and people imagine them much like open sourcing a piece of code, and it's so awesome that we have GitHub and all the open source stuff there. But I do question the usefulness of open sourcing a model, because what do you do with a model? What's in a model? It's not an algorithm. It's a trained mathematical model. And some people can look at that and make sense of it and write tools around it to make sense of it. So it's useful to some extent, but it's not as understandable as a piece of, say, Python or C# code would be. So, that's question, but it's still nice that they make a lot of stuff open source. But then also some of these models are just massive. You couldn't download them to your computer. Then some people say, well, I want to see the training data. Well, the training data for some of the OpenAI stuff is everything that's publicly available on the internet. You already have that available. Well, how do you go ahead and download the entire internet, right? It's not a manageable amount of data that you can make sense of. So That's an interesting aspect. But fundamentally, OpenAI is this company that has as its goal to research and develop AI technologies. It's now 49% controlled by Microsoft, and then there's another 2% that I think go to some of the original founders of OpenAI. So together they control the majority of OpenAI. And it's always, the entire thing has always run entirely on Microsoft Azure infrastructure. So Microsoft Azure Cloud is driving a lot of this. And as a question online about structuring your knowledge base, we'll get to that in a moment. So that's who OpenAI is. So now Microsoft has a partnership with OpenAI, and they make a lot of the OpenAI services available through Azure, but you can also use OpenAI directly by just going to the OpenAI website and just using it, or more interestingly, signing up for their services. So one of the things they're doing is the service called Dall-E. Dall-E is an image generation service. It allows you to have an AI draw you new original paintings and this art and so on. And in fact, I'm showing a Code Magazine cover here. This cover of Code Magazine was entirely produced by Dall-E. It's not something that it modified. I didn't use two bears and modify them together or anything. It drew this from scratch based on a certain prompt I gave it. And it came up with something that we felt was good enough to put on the cover of a magazine. We were, I think, the second magazine in the world that used an AI-generated cover art. So that's an interesting service. That's available directly on OpenAI. You can pay for that. You can even use it for free to a certain extent. You can also use this programmatically. So if you're a programmer, you can integrate with this and have it programmatically create images for you. So that's interesting, but not our major focus today. Our major focus today is ChatGPT. GPT stands for Generative Pre-trained Transformer. It basically is a language model. It's what we call an LLM, a large language model, and it is trained on language patterns. And we're going to do another Code Presents about a month down the road by my good friend and colleague and employee, Dr. Otto Dobritzberger. And he is going to explain how these large language models are actually trained. So if you're interested in the math behind that and how this language calculator or text calculator works, we'll do a special Code Presents on that. But for our purposes today, this is a really, really fancy chatbot that makes a lot of amazing things work. So we can just bring this up here. I have ChatGPT loaded up here. And you can go to that. It's just chat.openai.com. And I would imagine most of you have already done that. And we can now start interacting with it. And we can say things like, hey, how are you? And it'll respond back to us. Now, it's not intelligent. It's just a text calculator. So it does relatively trivial things. What it really does under the hood is it always predicts the next most likely word. So if I do something like this, I say I climb up the apple tree and I'm picking Anne, and I wanted to finish that sentence for me in a single word. As humans, we can probably say, well, it's easy. It's going to say apple, right? And so let's try it. And of course, it says apple because statistically, based on the sentence I just gave it, that is by far the most likely answer that it will give, and hence it comes up with that. Now, that's a very trivial example, but that's at heart what it does. Now, I can give it a much more complex task. I can say, tell me a Sherlock Holmesian story about a stolen apple, and it will go on and be very, very wordy, and tell me a new original story in a Sherlock Holmesian fashion. It'll probably have the typical characters. Here we go, Holmes and Watson do blah, 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 blah. And it'll go on and it'll tell me a lengthy story that's created right now. This story has never existed before, but it follows the patterns of what Sherlock Holmes would do, or what a typical Sherlock Holmesian story would be like. And as you can see, it goes on and on and on, and it's a very wordy bugger. But at heart, what it does, it just always predicts the one most likely next word based on this task that I gave it. And with that, it can do very, very interesting things. So I could say, let's start a new chat here. And I could do things like, what is the best surfboard wax? And it will tell me about different surfboard waxes. Now, what it doesn't do is, it doesn't necessarily base this on fact. This language model has been trained on data that I think with the latest model, it's up to 2021 in the fall or something like that. And it's trained on the data on the internet, but it's not like a web search. So it just says, based on the language that I've observed humans use, this seems to be pretty good surfboard wax. Okay, and it gives us up different answers. Now, I can do further interesting things. I can say from now on, you pretend or you act like you are working for Code Magazine. Only answer questions related to code. Okay, so now it says happy to assist you. And now we ask it the same question again. And now the answer will be different. The answer will now basically be, once it returns the answer to me, it will basically be, I can't answer that question because I'm only answering questions related to Code Magazine. And somehow we lost our connection to it, I guess. But anyway, it doesn't matter. So the point here being, what this is it's essentially a text calculator. And it takes all these responses. And somebody online says I broke ChatGPT, apparently so, but it doesn't really matter. It takes all the text that I previously gave it. It has context in that sense. And it then returns the most likely statistical result, right? And so in this case, it took a little bit, probably very busy, and I'm not paying for the expensive version. But it says, no, I'm not working for Code Magazine, and so I can't answer that question. But it would answer questions about the magazine. Now, it doesn't sit there thinking, oh my God, I'm now working for the magazine. What would that mean? If somebody asks me this, how do I pretend to work from Code Magazine? And I must be careful not to answer the surfboard wax question. But instead, it just says, the most likely statistical response to everything I've heard before cannot include surfboard wax questions. It must be related to Code Magazine. And so that's what we are, in fact, doing there. I'm going to stop it right there. It seems to be busy right now. And again, I don't have the paid version, so we're not doing that. So that's very interesting. And a lot of people have worked and do very interesting stuff with this. Like I could do something like this. I could go to Code Magazine, their own website, and I could go into one of our current articles. Here is an editorial that our editor-in-chief, Rod Paddock, wrote. And the entire internet seems to be pretty slow. I hope you guys are still getting good streaming performance there. But the basic idea is I could take one of those articles and I could paste it in here, and I could say, give me an abstract for that article. And it would summarize that article for me, because that's statistically the most likely correct answer for it. Okay? So, and we don't need to bring that up here right now. Somehow the internet is not cooperating, but it doesn't matter for the purpose of this talk, really. So that's what ChatGPT is. Now, it's tremendously useful. But what I need you to understand is what we are currently seeing with ChatGPT, and what everybody is all excited about or up in arms about or whatever, is really just a tech demo. It's a demo of using pre-trained large language models in a certain way that acts as a chatbot. The real interesting part about this is not this one tech demo. The interesting part is the technology behind it and how we can use that in the future. And in the future, we will use that to build very, very interesting and exciting applications. And one such use we are starting to see with Microsoft. Microsoft has now entered what they call the age of Copilot. Microsoft Copilot is this new paradigm. It's a paradigm shift on the level of the shift from DOS to Windows, or or from Windows to mobile or any of those paradigm shifts. It's a massive shift in how you will interact with software. And we can see Copilot in a number of ways. The first Copilot that we ever saw was the GitHub Copilot ecosystem. And a lot of people are using that, and that's going to be very important going forward. And what it is a Copilot that helps you write code in Visual Studio and in Visual Studio Code. Now, that's what most people think of when they hear Copilot, but that's one very, very specialized version of Copilot that just happened to be the first one in the market. The more widely rolled out Copilot ecosystem would be one built into Microsoft apps like Microsoft Office. So you can imagine a Microsoft Word Copilot that helps you write documents. You will have a Microsoft PowerPoint Copilot that helps you create PowerPoint presentations. And the things that you can do with Copilot are amazing. There's this website that you can go to called Reinventing Productivity that Microsoft put out. And you can go in here and watch some of these videos. These are short videos of some first appearances of Copilot in different Microsoft applications. So we'll just watch one of those really quick. And what this is, I don't have any sound, but that's fine. We're seeing Copilot here used in a Teams meeting. So let's say you do a Teams meeting and you can't attend it, but you still want to follow it. You can now use the Microsoft M365 meeting to still attend the meeting even though you're not there. You can then ask Copilot to summarize this meeting for you. So you get a total summary of what people talked about in the meeting. You could then maybe, if the meeting is half done, you could join in. You can say, what did I miss? You could then say, what are the major factors that were considered? And you see Copilot running over here in the side pane. That's one way to use a Copilot. There'll be different interface options. Copilot will then summarize things for you. You can then ask what else is related to it, and it comes up with amazing answers to that, and it even gives you references, like in this case the transcript. You can then do things like go in and say, okay, well, now create a Word document with more detail. You can say, create me a PowerPoint presentation. And those are some very early uses of Copilot, and you'll see that in Office and other Microsoft applications. And I encourage you to go to this Microsoft Reinventing Productivity up here URL and watch some of these short videos, because they are already pretty amazing. But these are just scratching the surface. What you will see happen is that Copilots will be built into every single Microsoft application. And it gets in particular very, very interesting when you see things like Copilot in Power Platform, where Copilot starts building new applications and all kinds of stuff. And you will see a lot more of these things coming in the build timeframe. So next week, it's Microsoft Build in Seattle, where they will announce a lot of new Copilot things. If you're not going to Build in person, you can watch Build online. And we are doing a State of .NET event in about 2 weeks, I think, where we are recapping everything that was there. So we will be able to tell you much more specifically the different Copilot things Microsoft is building. The important stuff for us to realize is that this will show up everywhere. It's a very advanced AI that sits on top of the technology that drives ChatGPT, but it's also widely integrated with many other things. It's not enough to just have ChatGPT. ChatGPT is the core engine that drives a lot of it, but it's integrated with your local data that comes out of Office and SharePoint and all those other things. Okay, so it becomes very much more useful. The question online about how do you integrate that data? I'll show you an example about that in a moment. Before we do that, however, let's go back into my browser here, and I'm using the Microsoft Edge browser, which is, of course, one of the Chromium browsers, so same general browser engine as Google Chrome. But what Edge now has that I find very interesting, it has this built-in Bing chat system. Okay, this is really a Bing Copilot. They're not using the term Copilot here, but that's essentially what it is. And I could go in here and I could say, what is the best surfboard wax? And it will go out and it will create an answer very, very similar to what ChatGPT does. And it uses the same AI models from OpenAI that ChatGPT does. And somehow I still have an internet problem. Try that again. But in any event, what this does is it uses the capability of ChatGPT, but it combines it with Bing. So it grounds this data in reality. ChatGPT just came up with things that it learned years ago and that seemed right. Bing first performs a search to find what the best surfboard wax is according to its current web search knowledge, and it then comes up with an answer that uses GPT-like features, but paired with current data. In other words, it's grounded. We call this grounding. It's grounded in factual data. So while ChatGPT, if it doesn't know the answer, may just start to hallucinate, because statistically a nonsensical answer may become the most correct one. But as a lot of these AI models become grounded in reality and real data, the answers become much, much more useful. Okay, there's a question online that says, my understanding is that GPT and Copilot access code and information that is freely accessible, but not necessarily free to use for commercial purposes. Do companies need to be concerned about that? So it is interesting, because ChatGPT is trained on everything that's freely available on the internet, which I think is perfectly fair. It's the same thing that Google does for its search index and has made billions and billions and billions of dollars, and we didn't seem to mind. And we don't mind if people go and use free information to teach themselves a thing or two. But some people say, I'm the owner of Code Magazine, like in my case, and ChatGPT used that to learn coding. Am I okay with that? Or am I less okay with that than Google indexing that and coming up with answers? And my answer is I'm perfectly fine with that. Some people may have different opinions, but then I think we need to revisit what it means to make information available for free. And people should not do that anymore and take it out of that. And then there becomes an interesting question around the right to be forgotten, because when it takes a year to train a model like that, we can't just take some of it out of it. And I think there'll be interesting legal questions around that. Now, for Copilot specifically, Copilot uses, in the Microsoft sense, in Office, uses M365 data that is yours. And that's one of the big things about Azure OpenAI. When using ChatGPT through the chat interface that I just showed you, that goes into ChatGPT and it's used for training. And if you don't want that data to be available to everyone, you shouldn't use ChatGPT through the chat interface. But if you're using it through Copilot, or you're using it through Azure, or you're using it even through the ChatGPT API that OpenAI provides directly, then your data remains yours. And that's a very, very important distinction to understand. So question is, Bing is connected to the internet while ChatGPT is frozen and confined. And that's correct. So in simple terms, the longer answer is, the chat part is still not connected to the internet, but Bing is, and there's a pre-processing step happening before ChatGPT kicks in, and we'll take a look at that here in a moment, how that works. But the short answer is basically yes. So that's Microsoft Copilot. Again, GitHub Copilot, it's been around for a while. Check it out. We have some recordings around just GitHub Copilot. It is absolutely amazing. And the productivity gains that are being measured are absolutely amazing. So take a look at that. So in general, though, in the bigger picture, what are the characteristics of using Copilots in Microsoft applications? We're talking about drastically improved overall productivity. The goal is, for the areas in which Copilots are used, a 50% year-on-year productivity gain compared to not using a Copilot. And the quality should be every year twice as good. That's the goal. And a cost reduction of 80 to 90% every year, year on year. And this situation is evolving extremely fast. Now, when you think about all this, if this is really true, if only half of this is true, if only a quarter of this is true, and it becomes very clear that if you're not buying into this type of AI productivity, your business will fall behind very, very rapidly. Or a country not using this, like Italy, will fall behind very, very rapidly. Okay. And what we are seeing is this concept of AI eating the world. We used to say in the past, we used to say software is eating the world. And what we meant by that is as soon as you bring software into the equation, it is the dominating aspect. So if you create a digital camera, all of a sudden it's more like a computer than a camera, right? If you're adding software to a phone, all of a sudden it's more like a computer than a phone. You can easily observe that. Compare a rotary phone to a smartphone. So software was very dominant, but now we're seeing that AI becomes very dominant. So as soon as AI is being added to any software that exists, the AI is becoming the dominant feature that consumes everything, which is very, very interesting. Okay. Now we're only at the beginning of all of this. The AI we're using is essentially the equivalent of toddlers. No singularity will result from this, but this will cause software to change drastically. And what people do not realize at this point, I think, and why I'm doing this talk, is copilots are not just for Microsoft. Copilots will start appearing everywhere. It's the new software paradigm, which leads us to the statement I'm making here. This is a very, very strong statement, but this is how we look at software internally at code today. Any application that does not feature a Copilot assistant AI is essentially legacy. If you're in the market and you're providing whatever, an accounting package, and it doesn't have a Copilot that assists your users, your accounting package will fall behind in the market very, very rapidly compared to your competitor's package that does. Conversely, if you can come up with a Copilot and you have this competitor that controls 80% of the market, this is your chance now to leapfrog this competitor. This is a paradigm shift on a level that is not coming around very often. This may be the biggest shift that we have ever seen in our entire career, potentially. So I'm coming up with some samples here. So let's talk about this concretely. How can you use this? Okay, this is what all of this leads up, and here's where we get into the real down-to-earth, concrete stuff that we now have in our apps. OpenAI for developers. If you have a Microsoft Azure account, you can now sign up for OpenAI as a developer. There's a wait list. We're getting into the whole AI apartheid problem a little bit there, but you can sign up for it and you will be approved sooner or later. When you have that, what you get is access to oai.azure.com. This is your playground where you can mess around with OpenAI. And you can do things like, you can go into the playground here and start messing with this and say, oh, well, what could I do? Oh, I have different models deployed here. And ChatGPT behind the scenes isn't just one AI. There's a number of different models that drive different parts of the ChatGPT experience. And so we could go into this playground here and we could pick a model that I've deployed into my Azure account, and I can now start putting in data, right? So while in ChatGPT we had a simple small text field to enter our data, this is now a bigger part of it. And I can do things like this. I can say, hey, provide me a summary of this article below, and I now see, oh, here is the article, and I can set additional parameters like the temperature. The temperature is this term of something where I can say I want a certain degree of randomness added. That's called temperature for some reason, right? And you can do all kinds of other stuff that I'm not going to go into here right now. But then you can go ahead and you can say, now run this, which is the equivalent of hitting enter in ChatGPT. And now we get a summary of what this article was up here, right? And here is the response that it created. And we can now go in here and say, okay, well, how did this work? Show me the code behind this. And it will give me a code example of how I could use this Azure SDK, call it, and get this result back. And here's an example in Python, which is a very popular language used for this stuff. But I could also go and find an example in C#, and you can see that there's a client API that you can use. You could also use this directly just through JSON or a curl interface, because it's REST services behind the scenes, right? And now we could go ahead and we could say, well, what else is there? Well, there's a chat interface, and I could now say, hello, how are you? And that would be very, very similar to how ChatGPT works. But again, we could look at the code that goes with this and how could we program that into our own apps. And there's now a number of different things we can set here. And as it turns out, behind the scenes, ChatGPT offers a lot of different options and parameters you can set. And most of those parameters are set in plain English, which is or any other language. I could do it in German or Spanish or Cantonese or whatever. And that's interesting. Language becomes the new common language runtime, the thing everything runs on. So I could do this, for instance. I could say, respond in the style of John Cleese of Monty Python fame. And I then save that. And that's what's called the system message. And now I could come in here and say, tell me a short story, just like we did in ChatGPT before. And now it'll start telling me a story. But then as you will read this, you will notice that this is in the voice of what Monty Python might be doing. Start this over. All right, so you can read through this, but you'll notice it doesn't just use what we call the prompt, but there's many, many more things that go with it, including things like the system message. Now, technically speaking, the system message is just another prompt that becomes part of the input and then makes this output. And I could go ahead and say, okay, tell me more. And then it continues on and it understands what has happened before. But the interesting part is it doesn't actually understand what happened before. When we look at the code, we can see that in order to make that happen, what it would pass into this whole setup is passes in the system message here as part of the message. It passes in what we originally said. Then in the second step, we pass it everything back that it created. And then we say, tell me more. And that's how context gets preserved. So it knows when we say, tell me about something, and then we say, describe it in more detail. It knows what it is because we are giving it the prior message again. So that's how context gets generated. But long story short, all of this is now available to us in a programmatic fashion. So for instance, I could go into Visual Studio Code here. And what I've done in Visual Studio Code is I made a Jupyter notebook. Okay. Then somebody says the system message is your secret pre-prompt, and that's correct. That's exactly what it is. So here is an example I did. I created a Jupyter notebook in Visual Studio Code. A Jupyter notebook is basically something where you can put some text and then you can intermingle a piece of code. So in this case, I intermingled a piece of Python code. So in this Python code, I imported the OpenAI package that's available for Python, and I pointed at my Azure endpoint that I created in Azure. And then I can call into this OpenAI SDK from Python like this. I say, use this particular model that I've deployed, and then here is my prompt. And this is interesting. It says, generate me a summary of the conversation below, and I want the output format to be this. What's the customer's problem? What's the outcome of the conversation? This is about travel. What budget does the customer have? What hotel does he want to stay in? What's the average cost per night for him? The name of the hotel. Is there free internet at the hotel? How satisfied are customers at that hotel? Blah, blah, blah. And then, as further grounding data, I'm passing in the conversation itself. So let's say this was a conversation that we had in spoken text that was transcribed to us, and we want to write a piece of software that can then analyze these conversations with this output format. Okay, well, we do this by just simply giving the GPT engine a special prompt. This is known as prompt engineering, which is the most important skill you can have in all this AI stuff. So we say, generate this output message based on this, and all of this would happen invisibly in a piece of software behind the scenes, right? And now I can clear my output here and just run this one more time. And now it actually runs and it connects to ChatGPT or OpenAI, and it creates this output and says, hey, this customer that we talked to here was looking for a trip from San Francisco and had $4,000, and in the end they decided to go to this hotel, and the cost of the hotel was this, and the hotel had free internet, and this is where they originated, from San Francisco, which is in the USA, even though USA never was in that original text. And so we create very, very interesting output by doing prompt engineering and calling into this programmatically. And so you can now see how this is becoming a development platform. That's really what this is all about, not the silly tech demo on OpenAI, but it's about the whole big thing. And if we now take this a step further, let me take you into Visual Studio, and I'm going to bring up a recent project here that I created in Visual Studio. And while this opens, there's a question online, and the question is, do we as developers train OpenAI? No, we do not train OpenAI, which would be much too big a task. It would take months, if not years, to pre-train the OpenAI models, but we can fine-tune them and we can ground them, okay? So here is an example of what I'm doing. This time I'm using the C# or the .NET SDK, and I'm setting up a connection to my OpenAI client. I want to create chat with OpenAI, and I can start here by creating a system message. So that's the equivalent of what we had in the playground. But I say in here, hey, you're a friendly and funny chap, used to amuse an online audience. You respond as if you were John Cleese from Monty Python, but as if you lived in the dark ages, in the medieval ages. That's what we want this thing to be configured as. And then we just run into a loop, and we just read an input from the console until it says exit. And until it does so, we just add more and more and more to our prompt chain and let it run its thing. So let's go ahead and run that here and bring my console window over here. Make it a little bigger, and I can say hello, and we'll then send that into ChatGPT. And hey, it says, good morrow, fair friend. Pray tell what brings thee joy and merriment this fine day. So it uses the system message where I said, you are now a medieval peasant, but with the humor of John Cleese. And I can go ahead and say, can you tell me a one paragraph story? And it will then go ahead and do so in the voice of a medieval peasant. And by the way, there's different ways to call this. There's the give me all the text at once, which I'm doing here for simplicity, or trickle it in like you see in most of these ChatGPT interfaces. So I can now, go ahead and say, make it longer, right? And it will do that. And what I'm doing is I'm taking all these messages, the message I send in and the message I get back and the next message I send in, and I add them to this chat log, and it becomes more and more intricate, and it knows what it is because I'm passing it back in. So as you watch this code running here, I have a list. Here we are, a list of messages, and I'm just adding it, and I'm resending it back in, and so on. So that's how a simple chat API can work, as we just saw it there, right? So let me bring that up again. So that's the basis of any development we do with ChatGPT and OpenAI. Now, the interesting part becomes when we really do bigger things with this. So let me bring up an older application we run within code. This is what we call our Olympus app, and I have a development version of it here. And this is where things get really, really interesting. And this goes back to Tim's question, how do we train OpenAI with our own data? And well, we don't. We ground it in our own data. We use the existing model and we ground it. So let me bring up this application here. So here's this app. I've used this app in a few examples. Let's open up my other screen. Well, let me get this over here. Man, I'm still having some slowness, but that's fine. So this is our app, and we maintain things like our customers or the articles we have in Code Magazine or invoices we send or consulting things we do. Our entire business is managed by this application here. But for now, we'll take a look at the article interface. And this article interface these are all the articles that we published. In this case, I looked at all the articles from our author, Rod Paddock, who is the editor-in-chief, and we can just pick one of those articles here and take a look at what's in this article. And so here's our article interface, and this article is called Wither the Sequel, and was published probably, well, in 06. It was his editorial. We could look at the actual content here, and he's waxing philosophically about some T-SQL new features or whatever the article might be. So now what we can do in here is we have a Copilot built in. This is based on infrastructure we have called Code Copilot, which is preview code at this point. It's not publicly available yet, but if you're interested in this will become a real product of ours, and we're still debating, should it be open source or what should it be? But what it basically is it's a set of components, and you can build this yourself, and probably will build some stuff like that in the future, that creates Copilot-like features in any application. And it does so by using the OpenAI ChatGPT engine, but it also adds things like interface components like this panel over here. It adds things like other AI, pre-processing, and so on. So what I could do here is I could say, generate me an article abstract. Okay, and when I do that, I'm just sending a standardized message into ChatGPT, and I include the actual article content here. And then ChatGPT comes back with the result and says, this is the abstract for this article. And oh yeah, that's pretty good. Certainly better than what we had in here before. And I could say, all right, accept that. And it sticks it into my application. So one aspect of this is driving the application. So what we've just done is we had a UI. We used ChatGPT under the hood, but we injected our own data, our own article data into the prompt by engineering this prompt. And then when we were happy with the result, we automated our application and stuck the result in here. But we could also start over with this one more time and say, okay, go ahead, generate me another response. And it has some warmth to it, which means it has some randomness, so it'll be a little different every time. And I could say, can you make this a little longer? And then it will respond and provide me probably a different version. And I could now chat back and forth with it until I actually have my correct answer on this. And, you know, I only have so much time here. Well, and this was more than a little longer, I guess. But, you know, I probably wrote more than the actual article itself. And I could now say, oh, that's way too long. Make it 2 paragraphs. And even if I misspelled a little bit, and we still have some AI weirdnesses in here, but that's fine. Even if I misspelled it a little bit, it will do better, a fine job. And so here's our 2-paragraph version on this. And you get the idea. We can now go back and forth with this. And I will show a lot more about that, how this is done in detail in my class about using OpenAI. Obviously, this goes into way too much detail here, but I will give you a brief glimpse to this, how this works. Here is how we do this. When we say we want to create an abstract, we create a chat message. We give it a system prompt that basically says, hey, you are a professional editor and you're creating an abstract that is useful for things like search results. And then we're injecting the actual markdown version of the article into it. And so it knows that, and then we say, okay, now here, generate us the abstract, right? So we engineered a prompt to automatically create an abstract when we do this. And we have other prompts, right? So we can do things like create categories, and then we pass in a different abstract, pass in a different prompt, I should say. So let's try have it create different categories for us, and it creates these categories. Now, these are all categories that we have in our database. I grounded it in these categories by telling it, I want you to create categories, but I first go into our system and I find all the categories we have in our database, and I inject those categories somewhere, I don't know where, here in our prompt, and say limit the responses to those categories. Do not invent new categories. And therefore, this result is now grounded in our data, and it won't hallucinate. Okay? So that's interesting. So now I could have whatever feature here, maybe modify the category slightly. But imagine what it just did. Just consider what it just did. It went in and it comprehended a technical article and extracted the categories from it, and it extracted an abstract from it. And I could do other things. I could say create a social media post. These are just shortcuts for people. But I could also do something like this. Do we have similar articles in our database? So this is interesting because I just gave it a plain English text, and it understood that it now has to search for articles, and it came up with a search term, T-SQL Innovation Modern SQL Tools. So it searches our database for that, and then it comes up with an answer. Ignore this thing. This should have just been a progress indicator, slight output bug that we still have, but it's very, very early versions of this. But it comes up with the response, and it says, yes, we have several articles in our database that discuss enhancements and improvements to Microsoft SQL Server and so on. Okay, well, that's interesting, but what are they? And say, can you provide a list? And it says, absolutely, here are the articles that are in that particular list. And, it gave me 9 articles that we have in our database. And I could now create this UI better. So maybe I could click into those articles, or I could link them here, or do whatever I want. Maybe I could say, hey, create an ebook out of all these related articles, for instance, and create new content based on this content we already own, because this is now just our content. And it doesn't go back to Microsoft or OpenAI. We own this content. It just is ours. But that's cool. So then I could say, okay, why is number 4 on this list? And it basically now gives me an abstract of what was in this 4th article that we have in our database. This is specific to us. This is not something Bing could do. This is not something ChatGPT could do. This is our specific implementation of a Copilot for our in-house app. Now think of what this just did. I gave it a simple text that said, do we have similar articles? So the first thing it now had to understand is that this query was about articles, because we have many other things. This could have been about what authors do we have that wrote similar articles? Do we have any training events about similar topics? Could have been about completely different things. It could have been, what's the weather going to be like tomorrow? So the first thing this had to do is it had to understand that this was about searching for articles. So how do we do that? Well, that in itself requires an AI, but it's relatively simple because we now live in this OpenAI world. And so what I can do here is I can say, when somebody enters a message, let's ask OpenAI whether the question is likely meant to search for articles, because searching for articles is one of the big categories that our app supports. And there might be 20 different things our app supports, but I just say, is this question, that this is the system message, and it says, from now on, is what was entered here, was that related to searching articles most likely? And answer only yes or no. And then I pass it in this message, and I'm running completely transparent and invisible to the user. I'm running ChatGPT to get a response. And if it says yes, I know that this is not about creating an abstract or anything like that. It's about searching other articles. Then the next step I take is I say, okay, well, now I need to search my database for the right articles. I need a search term. I need a query, basically. So I'm asking OpenAI and say, hey, provide me a likely query. It then gives me a query. And then I have a different, this is a microservice I'm calling in our own infrastructure, where I can pass in that search term that it generated. And this is behind the scenes in this particular example, driven by Azure Cognitive Search. So we have a database of articles in SQL Server, but there is an Azure Cognitive Search index over it that uses AI to search. And I'm passing in the search term, and it gives me back, in this case, I'm looking for the 10 most likely articles. And then I'm taking the content of these articles and I'm creating a new message into ChatGPT and say, okay, considering we have these articles there with this content, now answer the original question you were asked. Okay. And that's how it comes up with these results, right? So let's do this one more time. Do we have any similar articles? First thing that happens is I'm passing that to ChatGPT and say, is this likely related to searching articles? It'll say yes. And therefore it says, okay, give me a search term. It came up this time, it came up with this search term. Now that's because the temperature is high. I allow it to create somewhat randomized search terms. I could have also set the temperature to 0 to get the same result every time and be more predictable. Then we have our little bug here, but as you know, fundamentally, it now comes up with a search term. I go search Azure Cognitive Search for the right articles. I retrieve the articles, and then I create another prompt where I say, given these articles that we now have, this answers the question that was online. It's like, how do I fine-tune my model to use my own data? I don't retrain it. I just ground it in my data. And this is one way out of several ways to ground your data. And then as a result, let's do this again. As a result, it should say yes or no once it comes up with the result. And no, this time it immediately gave us a list of articles because that was in the search term. Okay, so very, very interesting things happening there. You can now play with that to your heart's content. You could now do things like you could say, give me a social media post for these articles, include hash tags at the end. And then it will take that context and it will do what I'm asking it there. And there's no limit as to what I can ask it because it's now responding in an intelligent way. So here are my social media posts for these articles that were in that result set. And I could now either automate the posting to social media, or I could copy that and post it into social media, or whatever it is. So I'm hoping you see that this is a first glimpse of this next generation platform that all of us will be building a lot of software on in the future. Okay, a paradigm shift like we've never seen it before, and I couldn't be more excited. Like if you think about what I've just showed you, and then you think about how would I implement anything similar without OpenAI and without these AI technologies, or how could I create an article management system or a customer management system, a CRM system, an item? This applies, I'm using articles as an example here, but this applies to all of your data. How could I build something that's as good without this? It's just impossible. And when I think of our database of articles and the abstracts we have, for instance, it is clear that I can just let this system go through all the articles we have and create better abstracts and have an immediate response, an immediate result that goes in minutes, which would have taken us months of work to create in the past. The productivity gain with this, the productivity gain in creating article abstract, in categorizing them, in creating social media posts, and in referencing things related to articles, and so on and so on and so on, is vast. It's way past the 50% that Microsoft is aiming for. So I'm hoping to have given you a first glimpse at this. We're going to now return back to our slides. I'm way past my time. Actually, the people in my chat here are already yelling at me that I'm going way too long. But I hope that this was really interesting for you and a starting point. Again, we're doing a full day training class about this, but also consider us a resource that isn't going to charge you for every question you ask. Contact us. We are more than happy to sit down with you and talk about how this applies to you. This will change everything. Every single application on the planet will have a Copilot in the future. And like I've told you before, we now consider every application that doesn't have a Copilot essentially legacy and in danger of being leapfrogged by the competition. So think about that. It's a profound statement. It's a big statement, but I really think that statement is true. Now, there's a question online. What is the link to request access to the Azure AI Playground? You can just go to OAI, like OpenAI, oai.azure.com, and that will guide you through where you can sign up for this. Okay. And if you don't get signed up, contact us. Maybe we can still help you with how you would use a lot of this stuff. Okay. Now, a few other announcements here. Like Jim said at the beginning of this presentation, you could really do us a favor by filling in the survey, and you can win a $100 gift certificate. It helps us tremendously in deciding what topics to cover in the future. So this is your ability to drive and steer the content we do. And by the way, I know there's further questions online. I'll stick around and answer all of them in a moment. Again, code staffing, Jim already talked about that. Exciting new endeavor that we have. We are disrupting the staffing industry. We are disrupting the mess that is the staffing industry. We are disrupting how badly people are treated in the staffing industry and don't have a real career advancement path ahead of them, don't get good benefits, don't get good pay, are basically treated badly by just about most, maybe not all, but most companies in the staffing industry. We are trying to do a lot of that different. We're trying to create a true startup, Silicon Valley type of vibe for a company. So consider joining us if you're interested. Check out codestaffing.com. Also, if you're looking for people, obviously, that can do a lot of this stuff, whether it's AI or otherwise, don't hesitate to give us a call. We are your partner for that. Now, we are investing hugely in AI and in what we call Code Copilot. We have this internal thing. It's really called Code Labs, but we like to refer to it internally as Code Skunkworks. We're having fun with that just internally. But check out codemac.com/AI. We're now doing a lot of services around this, anything from these pilot projects to executive briefings to making recommendations how this affects you, to actually implementing large-scale systems and even standard products around AI. So this has become a very, very big part of our business. So don't hesitate to call us if you need anything like that. Another big part of our service, like Jim mentioned, is security, which is kind of related, doing a lot of stuff there, training classes, all kinds of other stuff. And again, got a lot of interesting events coming up. If you want to learn more about Microsoft Copilot in Microsoft products, as well as a few other things, we will have a lot more about that in our Build Recap State of .NET, which is going to be another free webinar, May 31st. And we have training classes coming up that are just paid training classes like Secure Coding, which is a 2-day class. Also, I am teaching a class in detail about how all the stuff that I've just shown you, scratching the surface type of level of today, how you can build these types of things into your own applications and do more integration of your own data, grounding in your own data, and so on. And finally, there's going to be another Code Presents. We're going to announce that on the website soon. It's going to be a month from now. And that is Otto doing an in-depth presentation on how the heck do these large language models actually work. How is this? Is it conscious? Is it truly intelligent? No, it's just math. And how does that all work? And how are large language models trained? And sometimes you even want to train your own for specialty uses. And sometimes for developers, it's just really good to gain an understanding of how this works. So it's going to be 75 minutes. I know mine was supposed to be 75 minutes too. I went way over. But it's going to be 75 minutes on Otto telling you how LLMs work. And you already know that. Slide decks and recording will be available on the Code Presents URL, codemac.com/codepresents. We'll send you a follow-up email on that as well. You can always subscribe to our YouTube channel and be notified. If you hit the bell, be notified when new stuff becomes available, such as the recording of this video. And that is it. I've gone a half hour over. I apologize. But as you can tell, I'm super excited about all this content. This is some of the coolest stuff I've done in my entire career. Again, we just scratched the surface here. This is the beginning, and I'm only able to show you tiny little bits of the beginning, but this is going to be so amazingly huge. And yes, some people have concerns about AI, and you can use it for bad, but the uses for good have upsides that are just so dramatic that I couldn't be more excited about it. And I'm also very excited that we can all be part of making this used for good. So now a few more questions. How could you tune a model with CSVs? So I'm assuming like Excel type of files. Well, there's any number of ways you can inject data. There is the prompt engineering. You can also create embeddings. There's the SDKs provide functionality for that, but there's no doubt that prompt engineering is the most important skill you can have in all this. So in my training class, I will go into detail about prompt engineering. So join me for that. Also, again, if you have a question and you just say, how could I make this better? Send me an email, send Jim Duffy an email. The emails are on the slide right here. You're going to get an answer faster from Jim, but I will respond to your email. I'm always behind, but I will respond. We won't charge you for a question or anything. So feel free to consider us a resource for that as well, but also consider attending our training class. I think it's a day well spent to get in-depth, detailed information way beyond what I can cover here today. Another question from Forrest is, how do we protect our private data when using these APIs? It seems we might need to run our own LLM in certain cases. So that's a really important question. And that becomes a question of who do you trust? It's really no different with Azure OpenAI than any other Azure stuff. Like how much do you trust when you stick your data into Azure Cognitive Search, or how much do you trust Microsoft when you stick your data into Azure SQL Server or Cosmos DB or any of those? The equation does not change for Azure OpenAI. So your data remains yours. You have a contractual right to this. Your data is not being used for further training if you use it through the Azure side of things. If you go into chat.openai.com and you prompt engineer your way into creating an abstract or extracting data from your article database or from your customer service responses to analyze how good you do, this will be used for further training. Don't do that on chat.openai.com. Use the SDKs like the Azure OpenAI SDK, and your data will remain yours and it will not leave your premises, so to speak. Now, of course, all this prompt engineering and embedding stuff is relatively tricky also because there's size limitations and you have to understand how to deal with all that. And of course, it would be nicer to just hook your data up more directly and just say, use this search index, use this SQL database, use this Cosmos DB database, use blob storage and integrate it into your responses. That is not currently supported. I'm sure Microsoft is aware that that would be useful features. Let's just leave it at that and look at build and see what's announced there. and probably next fall there will be interesting announcements. Again, we're just at the very beginning, but integration of your data, even your on-premise data, would be very useful, no doubt. Okay, so clearly those are things a lot of people are looking at, and clearly everybody has the same concern. I want my data private, and my recommendation is go through Azure to do that. That is your safest path. But the question is, can you run a large language model on your own? Well, you can maybe run some simple LLMs on your own infrastructure. But the infrastructure we are talking about to run a large language model like GPT-4, we are talking data center size infrastructure. You're not likely doing this on your own. Microsoft is building data centers right now at a pace of 2 to 3 a week. Some of them are buildings a mile long and a half a mile wide. You are not going to build that type of data center yourself, I don't think. And maybe the statement is, maybe one of you in the audience says, oh, but we are big enough to do that. Great. But is it still worth it? Questionable. And the majority of us are not going to be able to do that. So large language models you run in somebody else's data center. I mean, they're petabytes in size. So that's the answer to that. Another question is, can you modify the Dall-E 2 image output and creative derivatives? Yes, you can, absolutely. So the Dall-E images, first of all, you can use the Dall-E service to not just create, but to manipulate things you've already created. And then that's yours. It's original art created for you by the AI. And you can then take that and fiddle with it to your heart's content. All right, and I think that was all the open questions. I think the other questions that we have flagged as not answered, I did answer. And so with that, thank you very much for attending. I hope you found it useful. Sorry about going over, but it's easy to get carried away with this, and I hope the extra content was useful. And like I said, contact us. We are thrilled to help you with all this. We got several skunkworks projects going on right now where we are investigating things for how customers are building new things in the future, and it's super exciting. So thank you very much. Hope to see a lot of you in 2 weeks for my build recap, stata.net, and also in a month for Otto's investigation of how large language models work. So thank you very much, and see you next time.